explain you that why this equivalent concept is so important and what is the utility of this equivalent concept, that we can apply this concept even when a balanced equation is not known to us. Okay, even if there is, we don't know what will be the byproduct, still we can use this concept. Okay, and also we have seen that how to calculate the n factor of different types of substances like acid, bases, salts, oxidizing and reducing agent. Okay, and today we are going to start with a numerical. I have written down the question here, and we will see how are we going to apply this equivalent concept to solve this numerical. Okay, so see what is the question. The question asks, find the moles of KMnO4 required to react with 1 mole of sulfite ion. Now for here, so what does it indicate? That KMnO4, which is an oxidizing agent, it is going to react with sulfite ion, and now products are not known. But see, I have told you, actually I'm writing in acidic medium because KMnO4 gets changed to different products and different medium. I've shown you that in the last class. So if I write here in acidic medium, KMnO4 changes to Mn+2, isn't it? And this is an oxidizing agent because from +7 oxidizing state it is reducing to +2. So what does it mean? It itself is getting reduced, so it will oxidize this sulfite ion. Now sulfite, see, this sulfur oxygen will remain. Oxygen's oxidation state is -2. Now here, what is the oxidation state of this sulfur? Oxygen -2 into 3, that is -6, and the total charge will be equal to this charge. What is -2? Not 0. This is not a neutral compound. So what is the oxidation state of sulfur? It is coming to +4. So remember, sulfur can have a maximum oxidation state of +6. So here, this oxidizing agent KMnO4 will oxidize sulfite to sulfate ion. Because in sulfate ion, sulfur will have +6 oxidation state. Okay? So the information given to us, we can write down this reaction. Okay, it is not balanced. There may be some other byproducts also. I don't know what are the byproducts. Okay, but still see, I can solve this question with the help of equivalent concept. But if I would have used mole concept, then I would have to know the balanced equation with stoichiometry. Only then I could use my mole concept. So here, say now how will I apply this equivalent concept? What did I said you? That equivalence of KMnO4 will be equal to equivalence of SO3 -2. That will be again equal to equivalence of Mn+2 equal to equivalence of sulfate ion. And that equivalence can be written as N/N, that is moles of KMnO4 into N factor of KMnO4. This will be equal to moles of sulfite ion into N factor of sulfite ion, and that is again equal to this and this. Okay, but in my question, I need to calculate the moles of KMnO4 which is reacting with 1 mole just let me put the values. Moles of KMnO4 are to be calculated. N factor of KMnO4 is 5. That is equal to 1 mole of sulfide ion into N factor of sulfide is 2. So finally, moles of KMnO4, what is the answer coming to? It is coming 2 by 5 moles. This is my answer. Okay, so how easily we can solve the numerical with the help of equivalent concept. Okay, so this is an application. Practice different types of numericals on your own using this concept. Okay, and again today we are going to start again a new topic, that is precision, accuracy, and significant figures. Now, so we are going to start with precision and accuracy, and then I'll need you significant figures. Okay? Now see how to explain this concept, what is precision and accuracy. Now, I'll explain this concept with the help of an example. Now, you might have seen that archers, what do they do? They hit a dot, isn't it? There is something like this. There are circles drawn, isn't it? And they are supposed to hit the center circle, the smallest circle. Okay. Now suppose I have taken two persons, A and B. Okay, there are two persons who are going to hit this dot. Okay, and suppose if they hit the center circle, means nearer to the center, then suppose they will get 10 marks. Okay, 10 points. And when they will hit this circle, they are going to get 9 points. If they hit this circle, then they are going to get 8. And this one, suppose they are going to get 7 points. And after this, they are going to get no points. Okay. So this is a game in which A and B are two archers. They are going to hit this. They are going to aim this point. Okay. And as they deviate from the center point, the points are going to get reduced. Now suppose the first person, that is A archer, he has hit, suppose, at this point. Okay, he has hit at this point. So how many points will he get? He will get 8 points, isn't it? And in the first chance, suppose the B person has hit here. So he will get 10 points, isn't it? Again, suppose in the second chance, A has again hit in the same point. So again he is going to get 8 points. And B this time, suppose he had, instead of hitting like this, he has hit now here. So now he will get 9 points. Again in the third chance, suppose A has again hit at the same point, that is this point. Okay, so again he is going to get 8. And B, again he has hit somewhere here. So again he is going to get 9 points. Now if I ask you who is the winner, who has got maximum points? So his total, A's total is coming to 24, whereas B's total is coming to 28 points. So if I ask you who is the winner, definitely B is the winner, because B has got the maximum points. But why am I giving you this example? See, now if I ask you who is more accurate, if I ask you who is more accurate, you will definitely say B is more accurate. Why? Because he has the actual value, or I will say the true value is this. So he is more near to or more close to the true value, isn't it? So B is more accurate. Okay? And what about A? A is not accurate. A is far away. This is 10 points, 9 points, he is around here. So A is not accurate, but I will say A is precise. And why will I say A measure value is accurate, then it has to be precise. So, but what about precision? If a value is precise, it will not be, it may or may not be accurate. But accuracy is definitely, if the data is accurate, it will be precise. Okay? I'll give you one more example to explain this. Now, here what I am doing, suppose in lab I need to measure the weight of a substance. Okay? The exact weight is suppose 2.01 gram. This is the exact value. That is the true value. This is called as true value. That is actual weight is this. Now again suppose I am taking two persons, A and B. They are going to measure the weight of that substance. Okay. A has measured in the first chance, he has got the weight, suppose 1.97 gram. Okay. And B has got the value, suppose it is 2.02. Okay. Again, see. In the second chance, A has got the value 1.98 and this time B has got the value 1.99. What does this mean? Means here again see A is, I will say A is precise because he is getting almost the same value repeatedly. But what about B? B for B I will say is accurate. Why is he accurate? Because his value is more close to the true value. Okay, so that is why you have to understand what is precision and what is accuracy. Okay, so remember the value which is given to you, this value, this is the actual value. And your 2.01 plus minus 1, you can vary from plus 1 to minus 1. It can vary. Okay, so this is not plus 1, sorry, 0.01. This value can, this much means 2.01, this 0.01, this value can vary. Okay, and one thing else you should be knowing, see, this value is actually called as the certain value. But what is the last digit? This value is called as uncertain value. Because suppose you are using a ruler to measure the length of a pencil. Okay, this is a centimeter scale. Suppose this is 1. Okay, here you get to see again this 1, 2, 3, 4. This is again suppose 1.5. 1, 2, 3, 4. This is your 2. Again this is 1, 2, 3, 4. This is 2.5. Again 1, 2, 3, 4. This is your 3. Now suppose the length of the pencil is, you have measured the value as 2.6 centimeter. 2 is actually the certain value. Why am I saying 2 is the certain value? And why I am saying 0.6 is uncertain value? Because see, when you are measuring, you are saying the answer is, the length of the pencil is 2.6 centimeter. But actually, this 2.6 centimeter, this value could lie here, means it could be greater than 2.5 It is the total number of digits in a number starting from the left, that is starting from the first non-zero digit to the last digit, okay, which is uncertain. That is called as the significant figures. What did I say? What do I mean by significant figures? It is the total number of digits in the number starting from the first non-digit number to the last digit, which is uncertain. That is called as significant figures. Okay, I've given you this example. That is, you have measured the length of the pencil as 2.6 centimeter. 2 is definitely certain, but this last digit we call it as uncertain. Okay, because 2.6 you have measured. Suppose when I measuring, I think it's slightly greater than 2.5. Okay, but it is less than 2.6. So what does this last value means? This means it is uncertain value. And in the significant figures, what are we going to do is, you are supposed to calculate the significant figures for different numbers. And there are certain rules for that. That for this type of number, how many significant figures are there. So see, what are the rules to calculate significant figures? My first rule says that all non-zero digits are significant. Okay, what is the first rule saying? All non-zero digits are significant. So, let me take an example. 2, 3, 5, 9. I have taken this number. All non-zero digits are significant. Here, how many zero are there? There is none. All are non-zero digit. So how many digits I am getting? 4. So my significant figures are 4. Okay. Similarly, if I take the example 0.75. Here, how many non-zero digits are there? 2. So what is my significant figures? The answer is 2. Okay. Now, second rule. See, any zero between any two non-zero digits, that is again significant. What am I saying? Zero between two non-zero digits is significant. Okay, for example, if I take, let me take this example, 2.005. So here see, the zero between these two non-zero digits, they will also be counted as significant figures. So total, how many significant figures will I get for this number? 1, 2, 3, 4. 4 significant figures are there in this number. Similarly, if I write a number like this, 7.003, again, these two are between the two non-zero digits, so they are also significant. My answer is again, how many significant figures? 4. Clear? These are the two rules. Then, third rule, what is the third rule says? I am having the first rule. Now, third rule says, in decimal number. Now we have come to decimal numbers, okay? In decimal numbers, 0 before first non-zero digit in decimal number 0 before first non-zero digit is not significant. Now what does it mean? I'll take an example again. Suppose I am taking this one 0.0079. This is a number, decimal number. So what does this rule says? The zero before the first non-zero digit, these zeros are not significant. So how many significant digits do I have? My answer is again 2. Okay? Similarly, if I take this example 0.0178, how many significant figures will I have? I will have 3 significant figures. Okay? Then, fourth rule. What does the fourth rule says? Again, in decimal numbers, zero after non-zero digits are significant. Okay, what does this rule say? That in the decimal number, zero after the non-zero digits will be significant. For example, 2.500. Okay, so the zero after the non-zero digits, these zeros will be counted for significant figures. So how many significant figures do I have for this number? The answer is 1, 2, 3, 4. Similarly, if I take one more example, 0.0783. How many significant, 3 and 000. How many significant figures do I have? All these zeros will be counted. But these zeros will not be counted because 0 before the first non-zero digit is not significant. But 0 after the non-zero digit is significant. So here, for this number, how many significant figures do I have? 1, 2, 3, 4, 5, 6. So my answer is 6. Okay? Then see, next two. For fifth number. Suppose a number is given to you. This is the fifth example. For a different type of number, suppose a number is given to you as 100. Here, if I ask you how many significant figures are there, see, this 100 can be written as 1 into 10 to the power 2. These are not considered as significant figures. How many significant figures do you have? 1. So for 100, how many significance will I write? The answer is 1. Similarly, if this type of number is given, this number means it can be written as 126 into 10 to the power 3. So this 10 to the power 3, this is not counted for significant figures. So how many significant figures do I get? The answer is 3. Clear? Then sixth example. See what is my sixth example? Suppose I have taken a number 3 and I am asking you how many significant figures are there. Now actually see, this 3 will have infinite number of significant figures. Why? How can I write this 3? If the number is only 3, definitely the significant figure is 1. But this 3 can also be written as 3.0. If it is written 3.0, what does it mean? The significant figures will be 2. Because this value, what does that actually mean? Means I have measured this value till the first decimal place. So the significant figures will become 2. If I write this 3 as 3.00, then my significant figures will be 3 because this value means I have measured my data up to the second decimal place. So the significant figures, total significant figures will be 3. Okay, and the last seventh example, see, you have learned Avogadro number 6.0002 into 10 to the power 23. For Avogadro number, if I ask you how many significant figures are there, remember 10 to the power anything. This type of numbers are not counted. You will just count these. 0 between non-zero digits is counted. So how many significant figures are there? The answer is 1, 2, 3, 4. Okay. So So this is how you're going to calculate the significant figures for different types of number. And last one more thing, for addition and multiplication. How to get the significant figures for the answer. Now see, suppose for addition. For addition, what are you going to do? Suppose the number given to you is 4.1 plus 2.036. This is the question given to you. I am just asking you how many significant figures will be there in your answer. Now, for addition, what is the rule? You will see which is your smallest number. Smallest means the number having the smallest number of significant figures I am talking about, not the actual values. Okay? So, which out of these two numbers, which will have the smallest number of significant figures? Definitely this one. Here there are two significant figures. Here it will have four significant figures. So your answer will also have how many significant figures? The number which has the smallest significant figures, the answer will also be having that many significant figures. And the same rule applies for multiplication also. For multiplication also, if you multiply this 2.1 into suppose 4.003. Here again, out of the two, which is the smallest number? Smallest insignificant figures. Here there are two significant figures. Here there are four significant figures. So your answer will have how many significant figures? Your answer will again have two significant figures. And the last thing, for rounding off. Sorry. For rounding off, see what do we do? Suppose I am taking a number 8.249. If this number is greater than 5, then we will round it off. The answer will become 8.25, isn't it? If the last decimal place is greater than 5, then the previous number is increased by 1. If the last digit is suppose less than 5, then it remains as it is. This is rounding off. But if suppose this number is equal to 5, then what will you do? If it is even, if the previous number is even, you will leave it as it is. But if suppose this number was something like this, it is odd number. This is 5. When I am talking about when your last digit, this is greater than 5, this is less than 5, and when it is equal to 5. Equal to 5, there can be two cases. Just the previous number can be even. If it is even, leave it as it is. If it is odd, then you have to increase it by 1. Clear everyone? These are the rules which you will be needing to calculate your significant figures and rounding off. Clear? Okay, go through this. Next class again we will